on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hi Vipul, good morning. Hey guys, good morning. Am I audible? Yeah, hi. Hi Arsha. Hi Udaya. Hi Rishabh. Hey Karthik. Well, so hope we are good to go for today. And so it's all about the virtual networks that we are going to discuss for today, which is for day 2. Any questions on the previous module? Yep, tell me Arsha. When I was trying to log into Azure RM account, okay. It's not giving the content on login page. It's not giving the content on login page. What does it mean? Are you meaning it from the PowerShell? No, you should get it. If not, you would not have installed some modules on that. Let me show you. Did you install the Azure? I mean the Azure cross-platform plugin, all those things. Then you should get it. Give me a second. Let me start the VM, and I will show you. Page is popping up, but it's not displaying the content. Are you working from a virtual machine, Asha, or from your local machine? Okay, let's see. Give me a second. Okay, sure. Let me take a note of this. Let's not waste the time. I will show you once after it gets logged in. However, we are going to work on the same. Okay, so I will show you once after we get landed up over there. Okay, cool. Any other questions? Well, so just as a recap of yesterday, we were working with the introduction of Microsoft Azure and excuse me. Yep. So as a recap of yesterday, we were working with introduction to Microsoft Azure. We were working with the Microsoft Azure Portal, PowerShell, and about creating a VM and preparing a lab virtual machine, which will be helping us to work on the days that we are going to move across. So that was the demo for yesterday, including PowerShell as well, to have an introduction about the PowerShell environment. And today we will be moving for the second module, which is about implementing and managing your Azure networks. So it's completely about the virtual networks that we are going to speak about, and it will deal a lot about what all the different sort of networking steps that we have in Microsoft Azure. So let's get on to the second module, which is about implementing and managing your Azure networking. And here you will be having the following objectives. So you will learn about how to plan and implement the virtual networks in Azure. You will make sense about configuring external and internal load balancing, implementing the application gateway, modifying the network configuration, designing and implementing a multi-site or hybrid network environment. So today's topic is completely about the networking concept where we are going to work on virtual networks. We are going to work about how you can import and export a virtual network, how you can set up a load balancer, the different types of load balancer, and in case if you want to establish a hybrid network, which is between the on-premise and the cloud, then how we are going to do that. So all these things will be discussed by today. Let's go ahead with understanding the basic overview of what is networking as such in Azure. So Azure networking comes up with a basic component called as virtual networks. So whatever the service, particularly the IaaS, like your virtual machines or anything that you're going to deploy on your virtual environment, which is on Azure, then you need something called virtual network. So the virtual network is a basic thing. The virtual network is a basic thing which helps you to deploy your infrastructure on the cloud. So you need to have a proper architecture, you need to have a proper plan about where I'm going to deploy my virtual machine, in which virtual network I'm going to deploy my virtual machine. So it's highly important because you should not allow other Azure resources, like let's say the other cloud services or other whatever the resource that you have in the virtual environment. See, the virtual environment is nothing but your cloud environment. Okay, so those things should not be collided with your virtual network. A virtual network is an isolated, separated network. Let's say, for example, you have Flipkart. Flipkart should have a separate virtual network for their server machines. It should not get collided with the machines of, let's say, their clients or anything like that. So the network should be isolated, which will help them to achieve their goals, which will help them to establish a on-premise environment connectivity, or let's say another Azure virtual network connectivity, all these things. So virtual network, I repeat, it's an isolated network. You should have an architecture about how you are going to lay your virtual network. So virtual network will be having a huge sort of address ranges. You should define the address range which you are going to select across. Okay, it will come up with a CIDR notation. You should mention the addresses, and inside the virtual networks, you will be having subnets where you're going to allocate the sub addresses for the machines that you're going to provision it over there. So the virtual network as a common, it's a secure connection between the Azure resource that you have in the VNet. Azure has plenty of resource with them. It has a virtual machine, it has storage, it has a let's say a web app. Okay, So you have plenty of things, and the virtual network ensures that each and every resource will not get collided with each other. Okay, so if you're to deploy a virtual machine, or if you're to deploy a web application, it should be deployed separately on a virtual network where it will not get collided with other Azure services. I hope you can make sense with the diagram that you have here. So virtual network is a separate layer. Okay, a virtual network is a separate layer, and in a virtual network holds huge sort of address range. So you're creating a subnet. Subnet is between, let's say, an address range. You're going to select a specific sort of address ranges alone. So that's one subnet, and inside that subnet you're going to deploy the virtual machines. Okay, so these virtual machines are deployed, and there you're going to filter the traffic using network security group so that the other Azure services will not be allowed to communicate with this particular subnetwork. I hope you're getting it. Are you clear, guys? Okay, cool. That's right. Thanks, Rishabh. So once again, I will repeat, you're having a huge sort of address range, okay? And inside that address range, you're going to create sub allocation, which is called a sub network. And there you will add a network security group. We ought to discuss about it. The network security group will work with traffic filtering where the other Azure services will not be allowed to communicate between that network. Okay, so it's an isolated network that provides a secure connection. Are you clear, Asha? Asha, can you respond, please? Okay, so let's go to the next one. So here goes the Azure Virtual Network, which gives you a heads up about how you can connect with the on-premise network. So you can connect the virtual network, okay? You can connect the Azure Virtual Network with the on-premise network environment as well. I hope you guys remember the one which I was speaking about for yesterday, the Visa and the MasterCard's example. Consider this is called your hybrid network. Okay, the one which you're seeing on the screen is your hybrid network. So now there are machines which are at Azure Virtual Network. Okay, you have virtual machines, and it does traffic filtering using network security group. And to establish a connection between this Azure environment and the machines that you have at the on-premise network, okay, you will be using this tunnel. You will be using this encrypted tunnel where it establishes a direct connection between a virtual network and an on-premise network. So ideally, what we do here is we call it as hybrid network. Okay, this is called as hybrid network, and yes, we will be working on this as well as of now. As of now, let's go for the virtual network, and then we will get back to this at the later of this today's module. Okay, so just make sense. Azure Virtual Network is there available on the cloud. Then it also helps you to connect with the on-premise network. Okay, so you can establish the connection between the cloud environment, I mean between two virtual networks on cloud, and also between the virtual network on the cloud and at the on-premise. So now getting in detail about the virtual network, it is your own representation that you're going to give it on the cloud. Okay, so you're going to create an isolation on the cloud. Maybe one subscription could have two virtual networks, or even two virtual networks can be on two different subscriptions. Okay, it can be of anything. You are going to make the design to be proper. You're going to allocate the architecture for your virtual machines. So in detail, the virtual network commonly stands for isolations. Okay, you can separate your virtual network for any purpose that you're going to put it across. So you'll be having a CIDR address, let's say for example 10.0.0/16 up to 10.0.0, whatever you're going to commit across. Okay, so now within this isolation, you're going to create subnets. You're going to give the subnetworks allocation within the virtual network. So when you go for this, the capabilities that you could have in the virtual network is that you could establish the internet connectivity. So internet connectivity in the sense you're going to come up with the IP, right? You will be having a public IP, we will be having a private IP. So all these IP addresses are ranged based on the CIDR address that you're going to give for the virtual network. Okay, so all the Azure VMs and the cloud service roles and the instance, all these things gets connected to a VNet by means of this internet connectivity having the VNet. So the multiple VNets can also be used to connect for multiple virtual machines. Okay, so let's say you have a virtual network in Southeast Asia and you have another virtual network at US, North Central US, something like that. So you can have two virtual machines, one at North Central US and one at Southeast Asia, and still you can establish the connectivity. So that we call it as VNet connectivity. VNet connectivity in simple is you're going to connect couple of VNets or more number of VNets, okay, and for that you will be using VNet connectivity. The best example that I could tell you is, consider that we are working for a web application like Amazon or something like that, okay, or even Flipkart. It also operates at India, it operates at Singapore. You can come across with anything. Okay, so it's like you have multiple environment where you need to get connected with it. So that's VNet connectivity, and you have Azure resource connectivity as well. So the Azure resource connectivity is to connect the virtual machines which are available on the same VNet. I would request you to take a note of all these things. VNet connectivity is for multiple VNets, okay, to establish connection between multiple VNets. And this, what you have, the Azure resource connectivity is for connecting virtual machines which are available on the same virtual network. Okay, make sense, please. So this is for within the same virtual network. The best example that I can tell you is, consider IRCTC. Okay, IRCTC is available within one data center region, let's say at India, and within India, you're going to establish the connection between the same virtual network. Okay, so that's Azure resource connectivity. Next comes your on-premise connectivity. The on-premise connectivity is to establish the connection between the cloud and the on-premise environment. So here you will be using site-to-site VPN. Okay, VPN is nothing but your virtual private network. So the site-to-site VPN is, or the private VPN connectivity is used to connect the establishment between the on-premise and the cloud. So this technology is called as routing. Okay, we call it as routing here. And next comes traffic filtering, where the traffic filtering is all about, like, you're going to filter the traffics which is going to communicate between the virtual networks inside the virtual machine and the connection through outside the virtual machine. So commonly speaking, it is about which connection to be allowed and which connection should not be allowed. So those sort of filterings, those sort of port address filterings can be done by traffic filtering. Are you clear, guys? Any questions? Okay, cool. Thanks, Rishabh. Thanks for responding. Hi, Vipul. Repeat VNet connectivity. Okay, see, the VNet connectivity is nothing but, consider you have multiple virtual networks. Okay, you have two virtual networks or three virtual networks in various Azure data center regions. In that case, what you will be doing is that you are going to connect the virtual networks to work for a particular web application. Okay, in that scenario, you will be using VNet connectivity. So, VNet connectivity is going to establish a connectivity between virtual networks, between, I mean, multiple virtual networks at different data center regions. Are you clear? Okay, thank you. Well, so the next is about the network isolation. Okay, so you can implement multiple virtual networks within each Azure subscription and Azure region. So I hope you guys remember, Azure data center region is a one particular region. Okay, And inside one particular data center region, you can have multiple locations. So let's say if it is India, you have South India, you have West India, and you have Central India. So here what we are saying is that the network isolation can be implemented between multiple virtual networks, okay, on each Azure subscription and Azure region. So each virtual network is isolated from other VNets. So one subscription can have multiple VNets, okay, and that can be isolated from each other. So you can establish a private IP address which will help you to connect with the virtual machines, okay, which will help you to communicate with the virtual machines. The next comes your network segmentation. So this is what I was speaking about. Consider you have a virtual network here. Okay, you have a virtual network, and the virtual network can have multiple sub allocations, which we call it as subnet. You can find subnet 1, subnet 1, subnet 1. Okay, so now what we are going to do here is you have a virtual network which comes up with huge address space ranges. Okay, it comes up with 10.1.0.0/16, and inside this 16 is called a subnet mask. Okay, the 16 that ends up is called a subnet mask, and this CIDR address can come up to a vary where you're going to split it for different subnets. Okay, so there's going to be a huge network, and inside a huge network you're going to create subnets. Let it be subnet 1, subnet 2, something like that, and there you're going to do the traffic filtering using this network security group. Okay, so the network security group is commonly about it establishes the connection, it establishes the communication between the networks. So now it comes up with two different things. One is your inbound and the other one is your outbound. The inbound is your incoming connectivity towards the server machine, and the outbound is the outgoing connectivity from the server machine. So whatever the resource that you have is connected to a virtual network having the outbound connectivity to the internet by default. So the outbound is like it can't get connected unless you specify that this port address should not be allowed. Let's say, for example, 3389 should not be allowed. You need to mention that. You need to say that this particular RDP 3389 should not be allowed. Only then it will block the connectivity. Okay. And you can also give the connection rules, like you need to make sense about the different port numbers, and you can establish the connection over here. So that's the major difference that we have in the network security group. The very first thing is, let's leave all these things, whatever we have here, make it simple. It is for traffic filtering, okay? And it allows you to communicate with the virtual machines, with the virtual networks. It comes up with two things as inbound and outbound rule. The inbound rule is for the incoming connectivity, and the outbound rule is for the outgoing connectivity. Okay, so the inbound comes up with the incoming connection, and the outbound goes with the outgoing connection from the server. And there you can do the traffic filtering based on the port numbers which you're going to address. To connect with the Azure resource, you will be using something called as NIC, which is we call it as Network Interface Card. Okay, so the network interface card will help you to connect with the virtual machines, your app service environments, your virtual machine skill sets, your cloud services, all these things. So basically, it's a connecting interface. Okay, so that's what we call it as network interface card. It's going to connect you with the virtual machine. It's going to connect you with the VM skill set. So the VMs will connect to the subnet within a VNet through a network interface card. A network interface will help you to communicate over the internet and also with the on-premise resource as well. So consider if you're going for hybrid connectivity, still the network interface card helps you. And when creating a VM, you will be creating a network interface card, which will come as a default. You can go to the resource group and you can find that you will be having a network interface card. The best example is I can go to this Azure portal, and to the resource group that we created yesterday. And here you can you find this? You have a network interface card. You have lab VM 646. So this is a network interface card, right? So this is a network interface card which comes up with the IP address. It also has a private IP address, and that is used for communicating. Okay, so it's attached towards the lab virtual machine. So the next comes your demo of designing the subnets. Okay, so the very first thing is we are going to create a VNet, and in the VNet we are going to fix a demo of coming up with a subnet for the same. So let's go ahead, let's start working with the demo of creating a subnet. Excuse me. Well, so I will go to the Azure portal now. So here in the Azure portal, please make sense. Okay, so here in the Azure portal, I will go for designing the subnets. So let's go for creating the virtual networks. So you can go for networking and let's create a virtual network. So the very first thing is we need to create a virtual network. Let's give this virtual network with the name Edureka VNet. And I will give the address as 10.0.0/16. Okay. And let's put it on a resource group, Edureka module 2 resource group. And I'm going to deploy it at a location of Southeast Asia. Let's name it as apps 10.0. So this address range should be within this address space. So 10.0.0/24. And you have a DDoS protection. Okay, this is, you can mix in here. This is a new service that Microsoft has come up where it is a paid one. Okay, that will help you to come up with getting a notification by the time of attacks and all those things. And you have service endpoint as well. Now let's click on create to create this virtual network. You can click here and find the notification. Okay, so this has been deployed. Let's go to the resource. And here you can create subnets. Okay, so now I'm going to create subnets. Let's go ahead. I will just go here and I will say that I will find subnets here. Should be having subnets. Yes, I have subnets here. So let's go for subnet. You have this apps which we created by default, right? So now what I'm going to do is, I was speaking about establishing the security, right? So I need to establish the security. I'll just click on the subnet, adding more subnet. Okay. So one, I have it for apps. Okay. So this is the public internet traffic that will be allowed in the front end web address. Okay. But the same can also be used to stop the backend network space as well. So this is how we are giving the available address location, and you can mention it, okay, with the address range that you have. Now if you want another one, you can mention it as data and you can give the address range. Okay, and if you need to establish the connection, you can give the, I mean, the traffic filtering can be done with this network security group. Let's get into these things in detail. Okay, as of now I will create another subnet and I will click on OK. Please make sense. We have created a virtual network and we have created a couple of subnets. Okay, and when you go here, you can find the data center location as well. It is Southeast Asia. Let's take a note of it. I was a bit wrapped up for today. Sorry, for yesterday. Okay. So let me make sense that I will add the video by today for sure. Okay. So let me just keep this added up. So the very first thing that we are working is on the demo of virtual networks. So what I have done here is I have created a VNet. Okay. So I have created a VNet with subnets for apps and for data. Okay, and here I have given the address ranges, and the data center location is Southeast Asia. I hope I'm right. Okay, so that I have created. Okay, hi Rishabh. uh, Wait, I have plenty of questions, give me a second. Hi Pawan. VNet connectivity and VNet peering both are same. Yes, both are same. VNet peering and the VNet connectivity are same. Hi Arsha. Are these subnets limited to one resource group? You mean the subnets which we are creating? No, it is not limited to a particular resource group. It is limited to a particular subscription that you have. See, it is based on a particular subscription on a particular data center location. Okay, for your subscription, it's not mattered about your resource group. And hi, Arsha, sorry, Rishabh. How VNet, how apps VNet came in that space? Did we create that manually? Yes, I created it. When I gave the name on the first blade, I said it is apps. Okay, I have created it. Any other questions? Okay, so let's go ahead. I will just give it here. Southeast Asia. Okay, cool. And now let's go ahead for the. So now I have created virtual network and subnets. Okay, let's go up with the static, public, and the private IP now. So the IP address plays a major role when you come up with the virtual network environment. So this is where it is used to communicate with the virtual machines. Okay. So let's make sense about what the IP address is about, what is static, what is dynamic, when we need to use all these things. Pavan, go from the basics, please. Okay, we are speaking about virtual networks. I showed you the objective. We will be speaking about VNet peering as well. Please travel along with us. Okay. Hi Ranjit. How to decide VNet IP and subnet IP range? It depends, Ranjit. See, you need to understand. Okay, give me a second. Maybe these links I can share it for you. This should ideally help you. Make sense with this. Okay, you have IP address range, you have different things like v4, v6. Okay, and just learn this. Okay, this will help you to make sense about how you can reserve your address. Okay, what is class A, what is class B, all these things. Okay, using 10.0, all these things is for higher networks. Can you find this? To design private network, for instance, for class A address, the address from 10.0.0 to 10.2.5 or reserved. Okay, so just make sense with these links. I will share you the link. This is like too basic. Okay, so I don't want to waste time with this. Just go with these things. Well, so the next is about the IP addresses that we ought to give it up. No problem, Bridget. So there are different types of IP address that we have and the allocation methods that we get into that. Okay, so there are two types of IP address. One is your public IP address and the other one is private IP address. And in that IP addresses, you will come up with a static IP and the dynamic IP. Let's first understand why we use a public IP address. The public IP address is used for communicating within the internet. Okay, let's say that you have a public facing services like event hubs, your Azure storage. Okay, all these things are public facing. Now this is a public IP. See, in this RDP, I have given the IP address, right? 13.67. So I'm consider this remote client is an external party. Okay, and it has to communicate with the virtual machine. It has to communicate with the virtual machine which is available on the VNet. So now I'm using the public IP. So you go here towards the virtual machine, and in the virtual machine you can find the public IP address. Can you find this? 13.67.92.157, and that's the same that I have given here. So this is public IP address. Okay, so it's allowed to communicate with the public internet facing services. Whereas if at all, if you want to connect within the Azure VNet or within the on-premise networks, okay, using a VPN gateway or express route, something like that, then you will go for private IP address. So if it is to establish a connection, simple, if it is to establish a connection, commonly you will be using private IP address. And the public IP address and the private IP address comes up with two types, a static public IP and dynamic public IP. The same for private IP, a static private IP and the dynamic private IP. So the public IP, which is static, is not assigned immediately. Okay, so this will be assigned once when the machine gets allocated, and when you delete it, it gets deleted automatically. The dynamic public IP is allocated and deallocated when you are going to start the machine. Okay, so now when you change this, let's say for example, I'm going to restart this. Okay, I'm going to restart the machine, or let's say I will stop this machine. Let's stop it. Consider this address 13.67, all these things. Hi Udaya, can we assign the same VNet for resource residing in multiple resource manager? No, you cannot do that. It is subjected towards one resource group alone. See, it matters about one resource group on one data center region. Okay, and hi Asha, is this public IP fixed? Yep, Asha, fixed in the sense it's not static, it is dynamic. That's what I'm showing here. If you want a static one, you can also do that. Okay, so it's getting deallocated. Let me start this machine again. Once after it gets deallocated completely, you will find a different IP address here. Let's wait for it. Public IP is assigned to this VM is automatically allocated. Yes, here we have allocated automatically, Pawan. Is it paid again? Yes, it is paid. It is paid within the 5 rupees what has been charged for you. It also charges separately, Chandu. If you're just creating a public IP, it will not charge you. Okay, if you're allocating it towards a machine or something like that, if you take it as a reserved instance, then it's going to charge. Okay, now we have stopped the machine. Let's refresh this. You will not find the IP. Okay, now let's start the machine again. Hey Pawan, like you said, the outbound is allowed in traffic filtering. So here the traffic is inbound. So have you provided any manual rules to access the VM from outside? No, I have not given any rules so far. I would also work on that for today's module. Okay, I'll show you how we can add that. Hey Joyrap, is this VM is under VNet that we have created now? No, it's not in the VNet that we created now. It is on separate VNet. Do we have types of instance here in Azure, same as AWS, spot instance, reserved instance? Yes, we do have it here. Okay, so let's refresh this to find the IP addresses. Can you find this IP address now? There's a change in IP address. Okay, it's 104.215. Okay, so it's called as dynamic public IP. And the same can be done for the private when you're going to connect the connection with the on-premise environment. Okay, when you specify if you want a static IP, then you can make it, or else by default you will come up with a dynamic IP. So whenever you do the patchwork or refreshing something like that, then the IP gets changed. Hi Chandu, for this module we are not going to discuss that. In future we will be discussing about it. Okay. Next comes the common scenarios of where we are using static IP addresses. So when you are to update the firewall rules, okay, which will communicate with your Azure resource, then you will go for a static public IP. Whereas if you want to take a control over the DNS servers on the domain mapping or the naming configuration, something like that, then you will go for a static private IP address. So these are like a common scenarios. For SSL, you will be using static public IP, and for the resource which you need to access from the other environment through an IP address, you will be using the static private IP address. Okay, so it just makes sense with all these scenarios. Hey Rajiv, if public IP is going to be changed, then any impact to access the site? Yes, of course, you will be having the impact on accessing the site, and that's where you ought to go for the static one. You should not go for the dynamic one. Okay. Well, so the next is about a demo of configuring static, public, and the private IP addresses. Okay. So for this, what we are going to do is that you need to go for the public IP address where you can find it on the Azure portal. So let's go to the Azure portal, and here you can click on create. Okay. And you go for network. You should find the IP address here. Oh, not here. Well, the better thing I can do is I can search for it. I will search for public IP address. Yes. And let's click on create to get it created. So here I'm going to name it. Okay, the very first thing I'm going to give is the name for the public IP address. Let's name it as Edureka public IP. Okay. And next is SKU. So this is a public IP's SKU. This must match the SKU of the load balancer which is going to be used. Okay, so if at all if you are having a load balancer, then it should match the load balancer's SKU. And the standard SKU is a new option that you have in the preview without that will go up without any SLA. Okay, so you can make sense in detail when you go here. You have learn more. I can give this link as well. The next comes your IP versions. In this IP version, you have to select whether you're going to move for IPv4 or IPv6 as such. The IPv4 can be used with either a load balancer with a network interface, or the IPv6 can be used if you want to use within load balancer as such. So for a network interface or a common load balancer, something like that, you can use IPv4. Okay, and the IPv6 is specifically for the load balancer alone. The next comes your IP address assignment. In this IP address assignment, you can say whether you're going to use a fixed IP address or the IP address which is going to be keep on changing when you restart it. Okay, so that's static or dynamic. And you have something as idle timeout. Next one. So the idle timeout is to keep a TCP or a HTTP connection open without relying on the clients, where you can send the live messages over here. The next comes your DNS name. This should be a unique name. So for example, I can give it as Edureka. I'm not sure whether I would be having it. Yes, I have that. Good. So let's create that. And if you need, you can create a IPv6 address as well. And select your subscription. Okay, I'm selecting Visual Studio Enterprise. And let's go for the resource group. I'll select the resource group which I created now. Data center location, and let's click on create to get it created. So that's about creating your virtual network environment with IP address ranges. So this gets created here. Are you clear? Any questions? Okay. So now the IP address has been created, and here you can find the IP address with the DNS name. Okay. So we have a DNS name here. No, I have not created the public IP with any VNet. I have just created a public IP. I have not associated that with anything so far. Okay, so let's go for the next one. So filtering network traffic with the network security groups. So the network security group is again with the inbound and the outbound connectivity. Okay, so it consists of the security rules that you are going to specify, which is to be allowed or which is to be denied. Okay, and that will be associated with the subnets, with the virtual machines, with the network interface card, all these things. And when a network security group is associated to the subnet, the rules will apply towards all the resources that you would be having on that particular subnet. And the traffic can further be restricted by also associating a network security group with a virtual machine. So commonly it is about either to allow the connection or to deny the connection. That's it. Hi Joyrup, we have just created the IP. We have not created the VM yet. Okay, so we will create it. Don't worry. Just travel along with us. Okay, we have the demo as well. I hope you saw the objective, right? We are going step by step. Okay, so now let's go for this network security group. Understand this flow, what you have. So you will be having a Azure host which receives the traffic. Okay, and it checks with the inbound rule whether it has to connect it or it has to deny it. So when you say yes, the load of inbound NSG rules by priority, it's going to get connected. The first rule will get connected and you're going to allow the packet for communication. If it is going to deny, then the drop will be, the packet will be dropped. Okay. So this we are going to mention it when we go for the network security group demo. So I don't want to waste the time. I'll just go for creating it. Let's go for creating a resource, and here I will go for networking, and I should have network security group here. Can you find this network security group? So let's go here, and here you can name the NSG. So I will say it as Edureka NSG. It should be on the same resource group, which is Edureka module 2 Southeast Asia, and let's create it. So once when you create a network security group, you can select subnets on that. Let's see if it is created. Okay, it's still getting created. Well, so let's go to this. And yeah, here you can find the connections that we have. Okay, so you have inbound and you have outbound. Let's click on the subnets and let's associate subnets for this. Okay, So you go here, you select the VNet which we created. So yes, it was Edureka VNet, and let's select the subnet which we have. Okay, so there you can say I will use apps, and let's click on OK. So the network security group gets added up. Now let's go to the overview, and here you can find you have something as protocol, right? Saying any. So the traffic from a different VNet to the current VNet is allowed. Okay, any mentions that allow VNet inbound. The traffic from any different VNet to the this particular VNet will be allowed. Okay, the traffic from the Azure load balancer to the current subnet will also be allowed. You can find it here. And deny is where the traffic from the public internet is not allowed. Okay, so the traffic from the public internet will not be allowed here. The same you can find it on the outbound rule as well. Now you can also create an okay, there's some question. When we can use dynamic public IP address? Karthik, I would request once again, okay, the flow will be broken. Okay, we have a proper flow here. You will be missing the topics if you are going from one topic towards another topic. Okay, we already were discussing about the dynamic public IP address. I even showed you the demo when we are using dynamic public IP search. I showed you starting a VM, and when we refresh it, it gets changed. If it is for testing or if it is for some normal development purpose, the lab VM that we have for dev test, something like that, in that case, we will be going for dynamic public IP. Okay, I also worked with a demo on that. I stopped the VM, I showed you how it gets changed. Okay, in that scenario, we will go for dynamic public IP. Just makes sense that you travel along with us. Please concentrate here, okay, because we have a shortage of time. We need to complete all the demo. If not, the loss is going to be on your side. Okay, so just check with that. When I explain a particular topic, please check with that what I am doing there. Okay, so I have completed public IP, I have completed private IP, all these things. Once again, I cannot jump onto that. If it is something theoretical, it's fine, but I cannot go to the demo and show you again. Okay, I have spent more than 10 minutes of time, so just focus there what I'm doing and what I'm explaining by that time. Okay. Hi Rishabh. Lower the number, higher would be the priority. Yes, you're right, Rishabh. The number that you set low, let's say for example 100, is going to be at a higher priority. Okay. And Tarak, can we able to rename the subnet? Yes, Tarak, you would be you can do that. Hi Ranjit, apps added in NSG, but we are not able to see here. Apps added in NSG, but we are not able to see here. You mean the subnet? You would be able to see that. See, we have just added it and you can find it here. Can you find this? In subnets, you can find it. Cool. Okay. Now let's go for the inbound security rule. So you have inbound security rule, and let's make sure how we can add the inbound security rule. Okay. So go for the inbound security rule, and there you can click on add to add the inbound security rule. So the best thing that you can do is you just click on the add here, and you get this blade. Okay, you get the source specifies the incoming traffic from a specific source IP address. Okay, so it will make sure whether you need to allow or it need to deny all these things. And you will be having a source port range. So the star, which is the asterisk, mentions that it can be a single port, okay, such as 80, or even a port range which will be from 1024 to 65535 port number. Okay, and it can allow any sort of communication. The same you have for the destination as well. Okay, and I'll say it can be 80, and the protocol could be TCP. You need to make sense about all these things. Okay, just learn what is TCP, what is UDP, all these things. And you were saying, right, Rishabh, I guess you were saying about the values. So the lower the value, the higher the priority that you're going to give here. Okay, so you can leave the gap between the rules here, like 100, 200, 300, something like that. And it's easier to add new rules also once when you prioritize based on it. And let's name it as for example, web traffic. I'll click on add. Similarly, same like this, you can also associate both the inbound and the outbound rules for the other, like for the data as well. Okay, you have other subnet named as data as well, right? You can also add for that. Are you clear? Any questions? What if two rules conflict each other with same priority? That should not be done. That's how you need to architect your virtual network environment, Rishabh. You cannot mention it on two things. In case if you're doing it, you will be having a SLA. Okay. Well, I hope you guys are clear until this, right? So we have deployed a VNet, we have deployed subnets, we have deployed public IP address, we have understood what is public IP, what is private IP. We have worked on network security group and we have understood what is network security group, how you can prioritize it, all these things. Chandu, priority is the priority that you're going to give for that particular port address and the communication that has to be done. Okay. Hi Tarak. Of course, the priority has to change for the other connections that you're going to give on the subnets. Any other questions? Okay, cool. So let's go to the slides again. So we have designed all these things. Okay, we have planned the virtual networks. We have defined the requirements, all these things. Now the next thing, let's go up is we have planned the VNet. We have planned the network security group, all these things. Let's go up with deploying a virtual machine with all these things, whatever we have here. Okay. So before that, just make sense about what we have here, the VNet peering. Okay. The VNet peering is, it can work on when you have the virtual networks which are available on the same data center region, okay, and the bandwidth between the resource will be peered between each other, okay, from one VNet to the other VNet. So the VNet peering normally works when it is available on the same data center region. The VPN gateway will be used when you have it on different Azure data center region. Okay, if you have it on different VNets and on the different data center region, then you will be using VPN gateway. So just make sense about the difference here. So to plan the virtual network, you need to ensure that which Azure data center region you're going to use, what are the connections that you're going to communicate with, okay, the prioritizing. So this is all what we worked. Okay, you need to take up a note of whatever the things that you have it here. You need to assign all these things. Either it's going to be at on-premise or it's going to be at cloud. Is it going to be on the same virtual network or different virtual networks? Okay, what are the permissions that you're going to give for it? Okay, so you need to mention all these things. We have questions again. Hi Chandu, we are not using the same port for all the other rules, but where priority comes. Chandu, we are not going to use the same priority. Of course, I agree with you. Okay. But what if you're going to give a connection as 3389 for one thing? Okay. And if it is going to be the same virtual network, which also holds a virtual machine, which is Ubuntu, and you want to give a 143 port address, something like that. Let's say your front end works with Windows Server and your Visa cards, MasterCards, all these details, your database, all these things are working on a database which is a open source platform and it is on Ubuntu. Okay. In that case, you need to come up with a different port address, right? Are you able to understand, Chandu? Well, see, priority is about setting up the priority for the port address and the communication that you're going to establish. Okay. So let's say you have a connection, okay, from port address of 3389. Okay. So the port address of 3389 has been set for priority 100. And you also have a port connection which comes up with, let's say, 3390, just a dummy port number which has been bypassed. So when it connects from 3390, okay, and it has been set for priority 200, now the first connection which will be established is 3389. Now if you say that I will also establish priority for 3389 with priority 200, then there will be a SLA. It has to check which has been established for the first priority as such. Are you clear now, Chandu? Cool. Hi Rishabh, why do we use VNet peering? Rishabh, try considering a web application where one web application is using Paytm, okay, and the same web application is also using PayPal, or the same web application is also using, for example, ICICI Internet Banking, something like that. So the Visa, or sorry, the Paytm gateway has been established with one virtual network, which is at on-premise, okay, and the same. I mean, the ICICI also uses the virtual network, okay, the same virtual network, which is again at on-premise. So when it is on the same VNet, then you will be using VNet peering. Are you clear? Well, I will make it even more simple. Consider you're going for Swiggy, okay? Swiggy as, let's say, for example, Swiggy as Swiggy banking, something like that. Okay, it has a virtual pocket. Okay, so you have that one in the virtual network. Okay, and consider Swiggy also holds another payment gateway. Okay, for example, some other X application. Okay, which is available on the same VNet again. Now to establish the connection, see, this is the couple of payment gateways will be on different address ranges, which will be on same VNet, okay, on the same different address region. Or I will just draw for it. Give me one sec, I will draw it. Mm, I don't have Camtasia, I guess. Sorry, any other notes? Okay, good. Consider this as a payment gateway, okay, payment gateway 1, and this as payment gateway 2. Okay, and at top it holds a Swiggy application on a VM. Okay, now this will be on a particular address range. Okay, let's say 10.0 something, let's say address range 1 or subnet 1, and this will be on address range 2. Okay, now this is on a separate VNet. Okay, this is on separate VNet, and P2 is on separate VNet, but both of them are on a same virtual network environment. Okay, both of them are, I mean that, sorry, not same virtual network, on different virtual network at India. Okay, now consider if you want to establish the connectivity for this particular virtual machine which holds the web application, what you need to do here is you need to do a VNet peering. You will be having a VNet peering here, okay, which has, and then you will connect it towards a web application, the front end web application. I will repeat it once again. When you have the payment gateways, okay, on different VNets on the same data center region, then you will be using this this VNet peering. I'm repeating it once again on a real-time example. Consider Paytm. Paytm works only at India. Okay, you have UPM, all these things. Okay, it has been associated with the net banking, all these things. Okay, now these things can work only in India, and you have Swiggy application which accepts Paytm. Okay, and in this sort of scenario, you will be using VNet peering. Are you clear, Rishabh? Rishabh, I'm waiting for your reply. See, it's not benefits, Rishabh. It's not benefits. It's a technology. It is a resource that you need to use for connectivity. That's it. Okay. The- See, what benefits you have in virtual machine? You can deploy a web application, right? It's not available on your environment. Instead, it is available on some virtual environment. Same like that, you're not going to buy channels. You're not going to take care of the risks that you have in the networking layer. You're just going to put up a virtual network on the cloud. That's it. Cool. Hi, Rajiv. First, we need to create the virtual network and deploy the VM. Is it? Yes, that's right, Rajiv. That's the proper way of uh, deploying your infrastructure. Cool, Rishabh. No problem. Well, now, how to go up with this? Okay. Now, to deploy the virtual network, you need to understand all these things. Okay, planning it. You need to come up with the name, the location, the address space, which is your CIDR notation. Okay, and you have the subnets that you're going to give within the address range, the DHCP options that you have. Okay, that's a property that you have for the DNS servers, and the array of the DNS servers that you're going to mention it over here. Okay, so consider you're giving all these things and the root table. Okay, this you need to make sense. You have something as root table. The root table we will be discussing it in detail. Okay. Now just understand I'm going to deploy a VM. Okay, within this virtual network. So let's go ahead on deploying this virtual network. Okay, on the VM. I am to do a demo which I missed it. Let's go for creating a resource, and then I will create a Windows Server 2016 VM. Let's name it here. Edureka VM2. I'll use a hard disk. Let's click use existing because we need to put it on the same VNet and the NSG which we have. So you go here and you click this Edureka module 2 resource group. Location, it is at Southeast Asia. Okay, let's click on OK now. And now I'm going to choose the virtual machine size. Let's go for DS1 underscore V2, or I'll go with a cheap machine which is A0. Yep, A1 underscore V2. I'll select this. Acha, yes, the VM on the virtual network should be on the same resource group. So I will go for leave these things. We will be speaking about this later. Okay, the availability set. Now scroll down and go for virtual network. Can you find this Edureka VNet? So let's select Edureka VNet which we created. And subnets I will call apps. Okay, the one which we created. And the public IP address I will call the public IP address which we created. Edureka public IP. So let's call that as well. And the network security group, it's going to be a basic one via RDP. Okay. And if you go for advanced, you can make the changes. You can go for the network security group and you can call the NSG which we created, Edureka NSG. Okay. So once after selecting all these things, you click on OK. And now you're deploying your proper infrastructure. You just say that create it. Let's wait for the deployment to be completed. Sure, Rishabh. Let's take a break for 10 minutes and we shall join by 10 minutes. Okay. What time we should be back? Uh, it's actually 8:15 now. Can we join by 8:30? 15 minutes? Chandu, that's true. In Azure, that's we feel that, even I feel that creating VM takes a bit long time compared to AWS. Harsha, yes, you should have some knowledge on networking. So we are creating today A1 V2 machine. Yes, that's right, Vipul. Chandu, is it reliable in real-time scenarios? Does the client accept this? Yes, the client accepts this. I don't think that's an impact that you have. The time taken for spinning up a virtual machine, it's just like 1 minute or 2 minutes of delay. Nothing as such. Well, let's join after the break, guys. Let's take the discussion further after the break. Hey guys, shall we start? Cool. Okay. So here goes the VM which has been deployed. Okay. And you should be able to see the public IP address. Or you can better go here for security. Sorry, not here. Let's go for the resource group networking. Yes, can you find this? Edureka VM and the web traffic which we added all these things over here. Okay. So this is how you can deploy a proper infrastructure with a virtual network and all these things. And when you go for this resource group, you'll be able to find the all components that you have here. Okay. You have this VM, you have VNet, network interface card, all these things. Well, so the further things are as like we go beyond on the role-based access control. So the role-based access control is where it defines what sort of user permissions that you're going to give for a particular virtual network or for a particular virtual environment that you have. Let's say a guy can be a classic network contributor or he can be the admin, he could be of anything. So you can define the user roles over here, and when you define the user roles, you need to make sure that what sort of roles you're going to define for a particular person. For example, I will give you this link. This should help you out to make sense about what all the different roles you have. Hardback for virtual networks on Azure. Right? So just make sense here. You have owner, you have contributor, all these things. The one thing that you can do is you go for this VNet and you go for this access control, right? And here you can find rule. Let it get loaded. So you go to the roles and no, sorry, not here. Let's go to this roles. Yes. So here you can find see the different roles, and when you go for this exclamatory, you can find what sort of roles that you have. So you are at virtual network, right? And you can go for the site recovery, network contributor, okay, all these things. Let's say manage the networks, all these things. So I can add any of the guy. Let's say, for example, Himesh at CodeSizzler.info. I can just add that person. I can make him as a network contributor over here. Okay. So that's role-based access that we have here. So this is all we have worked on it, designing the VNet. Okay. So to design the VNet, you say that you have number of subscriptions and the number of VNets that you have, all these things. Okay. So I quickly want to go for something called as route tables. Okay. I hope you guys, or let me give you a heads up about these things and I will go. Okay. So when you plan your VNets and when you have deployed your VNets, you should make sense about the number of subscriptions and the VNets that you have used and the number of subnets you have used, all these things. So only based on those things you can fix the route tables. When we were working on adding the subnets, we are working with network security group, but we did not work on something called as route tables. I can show you here. Let me go for this VNet and I go for the subnet. When I go here, you can find route table. Okay. So this route table is where you need to manage like what sort of subscription you have used, all these things. Okay. So here what we will be doing is you need to make sure the VMs has to be placed on what location as such. So you need to design the VNet first in a proper manner. So the VMs that need to be placed in different Azure locations or the workloads that needs to be completed, which has to be isolated, these things you need to keep it on mind. Depends on what sort of web application you're going to build it. The VNets in Azure are regional and they cannot span the locations. So you need to make sure that you have at least one VNet for each Azure locations to host any VM. So in case if you're not saying that I'm not going to create a VNet, Azure will create a VNet automatically when you create a VM. Okay, so without a VNet, there's no VM. Okay, without a virtual network, you don't have any VM. You can also create separate VNets and you can use it as we have did right now. Okay, the limitations that you have is that you can use one data center region for one subscription for one virtual machine. You cannot have two VNets for one VMSH. So that's one thing. And you can also have multiple subscriptions to increase the limit of resource. For example, I showed you yesterday on the PowerShell, right? I had multiple VNets. You can also sorry, multiple subscriptions. You can also use that. Okay, and you can use a site-to-site VPN for establishing a connection between the on-premise and the cloud environment, or you can also use express route to connect the VNets, which will be in different subscriptions. So, for example, again, I will go for subscriptions here. Give me a sec. Oh, I have only one subscription. Okay. So consider I have, for example, some three subscriptions or anything. And to establish the connectivity between virtual networks, which are at different subscriptions, I'll be using something called as express route. Okay. So that's another networking component that we have here. So consider the scenario, you have a single subscription and you have two VNets for an app. Okay. So here you have Visual Studio Enterprise, you have only one subscriptions and you have two VNets. Okay. You have two VNets and two subnets on each. One subnet is for production, one subnet is for development on VNet app 1. And VNet app 2 has again two things. So the advantage of this is that you can have only one subscription to manage it. Okay, so only one subscription you have where you're going to manage these things. Now, in case if the design is like you have one subscription but you have two VNets for an application, okay, it will be using two VNets for in one subscription. Now, can you tell me one simple example where we will be using this sort of scenario? Two VNets per app on one subscription. Guys, are you there? Region based network. Uh, yeah, region based network. Well, once again, I will come back to the same Paytm, right? So it is on one subscription, okay, on an app. Let's say, for example, Paytm app itself, and it can have multiple VNets. It can be one can be for FastTag, another can be for let's say Paytm banking, something like that. Okay, so different VNets. The next design comes up for one subscription per business unit and two VNets per app. So here it depends on the client. Okay, to balance the subscriptions or the VNets, you will be using this. This depends on the client. Like service-based companies like Wipro, Infosys, all these guys will be using such a sort of architecture where you will be having one subscription. Okay, and you can do the splits into the business unit. Like I have done it here. I can show you. See, I'll go to the resource groups and in the tenants, the subscriptions have been defined here. Okay, I have created tenant and I have shared it. Same like that, you can do it here. They have done business user 1, business user 2, and they have shared it. Okay, so that's one scenario. And the other scenario is one subscription per business unit and two units for a particular group of apps. So let's say whatever the applications which use Paytm will be on a different VNet, and whatever the applications which uses PayPal will be on different unit. Okay, so those sort of architecture can also deploy. So here goes designing the number of subnets that you have. You should consider multiple subnets always in a virtual network. Okay, when you go for these scenarios. So you don't have enough private IP address for all network interface card in a subnet. In that case, you will go for multiple subnets. If your subnet address space does not have enough IP address, okay, like you have allocated machines for almost all IP address ranges, then you will be having multiple subnets. Security. If you want to define the traffic filtering on different subnet ranges, then you need to go for it. Hybrid connectivity. If you want to use it between on-premise data centers and the cloud to establish express route or something like that, then you will be using it again. And virtual appliances is when you connect across the globe to come up with a firewall and you need to use your own subnet or something like that, then you will use virtual appliances. So this is again the design pattern, okay, that we have where you can design the subnet for each and everything. So this is all what we were working on. A subnet we were adding the NSG. Okay, so this we have done, deploying VM onto a VNet. Next, modifying the network configuration. We can have multiple VNets on same subscription. Yes, Pavan, you can have it. See, for example, we have done that already. I can show you. Let's go here and I will select virtual networks. Can you find this? This Edureka VNet is what we created today, and this Edureka RG VNet was created yesterday when you created LabVM. Okay, so you can have multiple VNets on the same subscription. See Visual Studio Enterprise on the same data center region. Okay, clear? Okay, so changing or modifying the subnet and the IP is so simple that you go here and you go to the subnets, you select the subnet, and you change it here. That's it. So simple. Okay, and the next comes modifying. Okay, this is fine. Next comes your UDR. Okay, you have something called user defined routes that comes on your route table. So we commonly call it as system routes in Azure. When you add VMs to a virtual network in Azure, you will notice that you will be having multiple excuse me excuse me. So when let's consider when you have VMs, okay, on a VNet in Azure, you can find the operations that will be happening automatically where you are not going to specify a gateway within the VNet on the VM. Okay, so there will be different subnets that will be having VM and that will carry on the instructions automatically. So when the VMs are communicating with each other over the network, you will be doing this. Or when the VMs are communicating with the public internet, again you will be having this, or even within the on-premise. So the system route is important whenever there's going to be a communication that's going to happen on a VNet. Okay, so it will manage the IP traffic that flows within the network. Hi Arsha, can one VNet VM communicate with other VNet VM? Yes, it can. That's what we are speaking. That's what we are showing here, the system routes. Okay. Can you find this? When VMs are communicating with each other over the network. So that can be done using this. So the control of the system routes is that it can be within the same subnet or it can be from a subnet to another within a VNet, from the VNet to the internet or towards the VPN gateway or VNet peering, anything as such. So it has a complete control over the communication. The system root scenarios of where you can use it is you can just have a simple setup with a VNet and you have two subnets, okay, and a few VMs along with the system routes have the IP traffic here. So you have a front end and you two have a back end, and the system route will take care of the communication within the virtual network. Why do we need a UDR? So the UDR is like it comes up with system routes that facilitates the traffic automatically on a virtual appliance. Okay, let's say that you have a hop of packets that has to be communicated, and you can define the next hop which has to communicate within the virtual appliance. Okay, so the IP forwarding and for all those things you'll be using this UDR. So you have a UDR scenario. It says which packet has to be communicated based on the subnets that you have allocated. Hi Chandu, VMs in different VNets within the same subscription or region can communicate without any exclusive setups like peer. Different subnet. You need to establish, Chandu, you need to establish with the private IP. Only then it can communicate. Okay, let's get on to this demo for designing the UDR. Let's go here and I'll create a resource. Let's go for networking and you should find root table. Okay, so go for root table. I've named it Edureka RT. Resource group, let's put it on the same. And yes, this is something new that we have, BGP root propagation. Let's click on create. Okay, let's go to the resource. And here you can go for the subnets. So you have subnets here and you can select the subnet that you need. You can just click on associate and you can select the subnet that you need. Okay, so there we go. You can select the subnets. Let's define the subnet what we created today. I will select this and for this also I will use apps. Let's click on OK. Hi Rajiv. It depends on the scenario, Rajiv. It's not mandatory that you need to add the static root here. If it is for testing or development purpose or lab, something like that, then you don't need to do that. So now let's add the root. Okay, so you can go for the roots and you can add the root here. Let's name the root. I will name the root as, for example, apps root and address prefix. So the address prefix is the destination IP address range, which will be in the CIDR notation that this route applies for. Okay, if the destination IP address of a packet falls in this range, then it matches the route. So you can just give it as 10.0.1.0/24. Okay, and you need to say the hop type. What would be the next hop type as such? Let's say I will go for virtual appliance. So this next hop will handle the matching packets for this route. It can be a VNet or it can be a VNet gateway, internet, or even a virtual appliance. So the next hop address you need to mention it here. For example, 52.172. I'm just giving some random address, 46.40. Okay, this is, I hope you're getting it. This is the hop address that you need to give from the virtual machine. Okay, and here I'm giving a random address. Chaddu, can we add inbound and outbound rule directly at VNet level rather than at subnet level? Yes, you can do that as well, Chandu. See, if you're doing that, you need to do when you're creating a virtual machine. But in a virtual network, you need to come for subnets, and only there you can do it. You cannot apply it for the entire virtual network as such. Now let's click on OK to get it created. So that has been added. You have your root over here. Okay. The next is about importing and exporting the network configuration. Let's go for uh, all resources here and we shall select the VNet. It's Edureka. And here you can scroll down, you can go for automation scripts. So you can find the configuration is available in all the best versions of the script here. Okay. And the all the different resource configuration along with the parameters which is deployed in this VNet will be available in the template. So this is the template that you have. Okay. Now you can just click on download. I will click on download here and you get it downloaded. Joyrup, I cannot repeat it now. Let me complete this demo. Okay, and then I will go back for that. So now you can you have downloaded the configuration which is at JSON. I will open this. Can you find this? It is on JSON. Okay, and you can use the same tool for communication as well. Let me open this and show you. Well, here we go. Okay, so it is on JSON where we have given the public IP, VNet name, all these things. So a better thing that you can find here is I will go for the finder and I'll also open the template and I'll show you. Yep. So here you can find, see, we have the VM2 VM name, okay, the Edureka name, all these things. So we have been using standard EA1 underscore V2 Windows Server Data Center. Okay. So this is what we call it as ARM scripts. This is what we call ARM scripts, and you can use these scripts for deployment as well. So we have deployed the VNet with the NSG, priority, all these things. Well, so the next one that we have here is about your Azure Load Balancer. Okay, Rajiv, yes, the same config can be applied for another one as well. Okay, someone was asking about UDR, right? Yes, this guy. Uh, so for UDR, you go here. Okay, go for routes on the networking, route table, and you need to create the routes here. Okay, you need to mention all these things and you have to create the routes, and once after you create it you will be getting it here like this, and you need to associate the subnet, and then you can connect the routes. You can go here and you can say what you need to use. Is that okay, Joyra? So once again from the start, why we use route tables as such. I told you, right? It is for communication, Joyra. It is for communication with your networks. I briefed you on this slide itself. I briefed you with a scenario also. So do one thing, guys. I'm repeating each and everything for twice with an example. Still, if you're not able to understand, once when I complete the session, please ask me. I will tell you. And still, if you're not able to understand, just go for the video recording, what you have, and then go through the video and make sense over there. Okay, because it will take a lot many time if we are again jumping back to the previous topic as such. Okay, we have around like 10 demos to be performed for every day. Okay, next is your Azure Load Balancer. The Azure Load Balancer is one important one. Okay, and you have something called as Application Gateway as well. So what we do here at the Azure Load Balancer is that the Azure Load Balancer will help you to make sure that your virtual machine will process high availability for your customers. Okay, so you can have it on a layer 4, which is on a TCP level or at a UDP level. Okay, which will distribute the incoming traffic towards the server machines which are available on the same data center region. So you will define the health prop saying that it's for 30 seconds or 40 seconds. If one server machine is not going to respond, then the next server machine has to take the control over it. So you have two types of load balancers as basic and standard load balancer. The basic load balancer is for general availability, whereas the standard load balancer is in a public preview now. So the load balancer comes with distributing the traffics with the request which comes to the internet, okay, towards the VMs. So we call it as internet facing load balancer, where it is a public facing load balancer. And the load balancer which distributes the traffic between the virtual machines inside a virtual network, okay, I mean internally or internally within the on-premise environments, are called as internal facing load balancer. And you have the forward external traffic to a specific virtual machine as well, you can which can distribute the traffics. Okay, so all resource in the cloud will come up with a public IP address where it's going to reach the public IP address, and then the load balancer will take a control about distributing the traffic between the virtual machines, which is a public facing, and you too have an internal load balancer which will distribute the traffic internally within the virtual network. So this is a best example that you have for internal and external load balancing. The internal virtual IP address is where you have an internal load balancer here. Okay, so when there's going to be a request on the public virtual IP address, you'll be having external load balancer which is on the front end, and that sends the request towards the internal load balancer, and the internal load balancer will distribute the traffic within the server machines which are available. So one is application server and then the one is database tier. This we call as public facing. From the internet you get a request, and this distributes the traffic internally, okay, which is on the inner level. The features of load balancers, or it goes with distribution which is on hash based. Okay, I hope you guys know the hash based 5 tuple hash algorithm. So it is composed with your source IP, source port range, destination IP, and the destination port range, and the protocol type that is going to be used. Port forwarding is used to do mapping. It is used to do how the communication has to be done on the inbound, which is managed. And this communication is included with the traffic, which is initiated from internal host. The automatic reconfiguration is where the Azure load balancer instantly reconfigures itself when you scale instance. So it is like when it goes higher in usage, then it distributes the traffic automatically, and it scales up or scales down when the traffic gets minimized and maximized. Service monitoring is the health prop where you're going to say that for this many amount of time it has to check, and then it can go for the next connection as such. NAT is your the common outbound traffic that you're going to originate, that you will get it from the internet, and you will give the same virtual IP address for the incoming traffic as well. So the NAT is nothing but the network address translation that you're going to do. Let's go for the demo of configuring the external and internal load balancers. Let's go here for the load balancer, and I will click on create networking load balancer. Let's name the load balancer. I'll name it as Edureka LB. So you have public facing and you have internal. Okay, so let's go for this internal virtual network. I'll go for today's virtual network, subnet on the apps. And here you have the IP address assignment. Either it's going to be static or the dynamic one. Let's put it on the same resource group. Let's click on create. Well, so now let's go to the resource. And here you can find the front-end IP configuration, which we were speaking about. You can go to the front-end IP configuration and you can add the front-end IP. And you too have the backend pools where you can add the server machines. You can click on add and you can add it over here. Okay, either a single virtual machine, you can find it here. See, we have single virtual machine. You can add it up over here. And you do have the health props. You can go to the health props and you can say for how much time it has to wait. Okay, you can click on add and you can say the time interval for which it has to wait and the port on which it has to communicate. So this is how your load balancer works. Any questions? Any questions? Okay. Do we have any tools to create the scripts? What scripts you're speaking about, Chandu? You're just working on Azure Portal, right? PowerShell. Oh, you have gone for that. Yes, we do have the scripts. You can Google for it at the Azure documentation site. Yes, Vipul, you're right. For backend, we need two virtual machines at least to distribute the traffic. Well, the next topic that we have is your application gateway. Okay, so the application gateway is same like a load balancer where it works on layer 7 level. Okay, it's for HTTP level. And you would be having another traffic filtering as well, which is using traffic manager. Okay, that's another one. So the application gateway is a dedicated virtual appliance which will work on the application delivery controller. So the application gateway is on layer 7, which goes up with load balancing capabilities for your application. The application gateway can also be configured as internet facing gateway or internal only gateway or even the combination of both the things. Here goes the features of application gateway. You have web application firewall, you have socket firewall, socket support, okay, you have cookie based session affinity, you have multi-site routing, advanced diagnostics, SSL security policies, all these things can be added. So you can combine the traffic manager and the application gateway. Now consider this as an example for Amazon or something like that. For example, I will show you. You go for Amazon.com. You're getting this right. You're on Amazon.com. You can visit Amazon.in as well. And when you say Amazon.in, you're using Traffic Manager. It comes for Indian server. And there it distributes the traffic within the virtual machines using load balancer or using the application gateway. I hope you're getting it. And the same for US as well. Okay. So this is how it goes for different regions and it distributes the traffic. The application gateway works on layer 7 and the traffic manager also works on layer 7. The application gateway can work only within a data center region, whereas the traffic manager can split the distribution on the cross regions of Azure. So here goes the difference, the technology used by load balancer, application gateway and the traffic manager. So you will be using layer 4 on the application, Azure load balancer. The application gateway will be using layer 7 and the traffic manager will be using DNS level of propagation. The application protocols which are supported can be of anything on the Azure load balancer. And the same for traffic manager, whereas in application gateway you have only HTTP, HTTPS and WebSockets. David, yes, you can also use application gateway with load balancer. Endpoints, you will be using Azure VMs and the cloud service roles for load balancer. And here also you can use VMs and the IP address, the internal IP address that you get for application gateway. Whereas in Traffic Manager, you can call the availability set, you can call the web apps, VMs, endpoints, external endpoints, okay, all these things. The VNet support that we have here is common for application gateway and the application load balancer, whereas for Traffic Manager, you have only internet facing applications. Hi, David. Application gateway with load balancer. See, when you're going to establish the connection, okay, commonly by using uh, TCP level, okay, and then you need to distribute that towards the multi web apps that you have. For example, like this, you have the DNS level of, give me a second. For example, like this, you have CodeSizzler.in and you have CodeSizzler.AzureWebsites.net. So here I need to distribute it on multi-level. Okay, in those cases I'll be using application level, application with a load balancer as such. Okay. Hi David. Okay. Hi Chandu. Application gateway and VPN gateway are same. Uh, it's like moreover same, but still we have some different features that varies on VPN gateway and application gateway. Chandu. Well, we shall go with the demo of implementing the gateway. Traffic managers for site-to-site communication. No, traffic managers again to filter the traffic between different data center regions. We will be working on it. Don't worry. Give me a break. Let me have some water and I'll join back. 2 minutes, please. Okay, thank you. Let's go with the application gateway. That's a final one that we have. Here we go. We need to go with implementing this application gateway. So you need to create a gateway subnet before creating the application gateway. So go to all resources here and select the VNet where you need to create it. So I will select this Edureka VNet and I will go for the subnets and there let's add a gateway subnet. So I am to add a gateway subnet here. So let's give the address. So at the end, it should be on the virtual network. So you give this address and you give the root table as well. You can leave it with the default option as we don't have a routing table yet. Okay, it will be discussed on the following things. So you can even call it if you need. As of now, I will just leave it. My part is over on the root table. Okay, so let's go here and I will click on OK to get it created. So that adds the gateway subnet. Well, so this subnet has been added. Now let's go for creating a resource. I will go for network and application gateway. So now here I'm going to give a name. Let's name it as Edureka Application Gateway. And tier you have standard and WAF. So the WAF is your web application firewall. Okay, it protects the web application from the common web-based attacks like SQL injection, cross-site scripting, etc. So if you need, you can go for the WAF or you can be at standard itself. Pawan, hi. The gate end, it should be for the front end which you have. Okay. So the next comes your SKU size. So you give the small instance size which are intended for development and testing scenarios. Medium and large would be the instance size for more intensive workloads. Okay, so here I'll go for medium itself. And you have the instance count, you can give it here. You can specify the instance count to increase the availability. Let's say 2, which is recommended for production workloads, and select a subscription. I'll put a resource group where we have the VNet, some Southeast Asia, and let's click on OK to get it created. It's asking for a DNS name, public IP, and the DNS name. Let's give this name here. Uh, DNS should be a unique name. I'll name this front-end IP configuration. Okay. Are you clear with these things, or you want me to explain again the front-end IP configuration? See, in the IP address type, you have a public and private, isn't it? If you select private IP, one will be selected automatically from the subnet, or you can specifically use any one of yourself. And if you're selecting the public IP, you will have to create a new one for your application gateway. Okay. So here what I will do is I will select public and I'll go for public IP address where I'm going to create a new one. And let's name this here Edureka public IP1, sorry, or let's say CodeSizzler public IP. And then you have the listener configuration. So if you set the listener configuration to HTTPS, the port will be 443. Okay, see, when I say HTTPS, the port will be 443. With the credentials, HTTP is the standard listener where you will be getting the configuration with port 80. Now, I'm using Windows Server, so I will go for port 80. And now let's go for settings blade. I'm not using web application firewall here, so I will go for settings blade and summary blade. And let's click on OK to get it created. Oh, I have not selected VNet. If you're using public IP, no, you need a gateway subnet. Only then it can get the communication towards the VNet and the subnet which you have allocated for the application gateway power. If you are using a public IP here to access front end, how the gateway subnet is associated? Pawan, do you remember the very first thing that we did is we went for the virtual networks. We created a subnet, okay, and there we did not associate the root table. What if you're associating the root table? What will happen? Yeah, so that's what it's happening here. It will get communicated with the gateway subnet if you're routing it. Here we have not done it, so it's not happening. Well, let's wait for this to be done. Once when it's done, we can go for the backend pool and we can add it. If we want to use WAF, then the front end listener port should be W. Right, that's right. That will be taken by default. Please add WAF also in demo if possible. That's not actually the part for this 533 Pawan. Better, I will do one thing. I will share you a document for that. Okay, you can make sense with the help of that. That comes for architect guys. Okay, it will take a bit long time for this. No, for these things you go with AWS. Even it will take a long time only. For the VPN gateway, all it will take 45 minutes for you to deploy it. Can we create a property using PowerShell? If yes, can you show a sample script and please explain? Pawan should have been for 532, I guess, right? It's completely with PowerShell. Okay, application gateway. You have it here, Pawan. Go to the documentation. Okay, whatever you need, go to the documentation page. Here in Azure, in documentation, you have it. Well, let's go to the next one until it gets deployed. Okay, so it's about the multi-site to site, all these things. These are theoretical things. So the types of hybrid connectivity that we have in Azure is you have point to site, you have site to site, and you have private site to site connectivity. So the Azure helps you to get connected with your customer's on-premise environment with all these multiple things as point to site, and express route. The best thing that we go up here is on the point to site is you have a client, okay, whom you're going to get connected with the internet, okay, and without deploying any special software, you're going to get connected with the VNet, which is on Azure cloud. So it contains some VPN policies that you can download into your computer, and you can use that on the VPN client, which comes as inbuilt on Windows machines. You can also securely connect to the VNet, which will be in the same way when you connect it towards the VPN clients to your company's corporate network. So this is also Windows Server, and the on-premise network is also Windows Server. So that comes as a default in inbuilt way for point to site. The point to site comes up with the Sstp tunnel, which is secure socket tunnel processing that will give you a secure connectivity for Azure from anywhere. Okay, so this capability enables you to set your prototyping, development, testing, simulation, all these things easily. So you just have route based, and you will use that to go with the site to site connectivity options. The next comes site to site VPN. So it's from one site to the other site between your on premise and your virtual network. And this will be using IPsec VPN tunnel, okay, where you will be using VPN devices, and it has to connect up to 10 on-premise site. You can use this IPsec tunnel. So that's for VPN site to site, and you have the IP level of connectivity. So the IP level of connectivity is between your on-premise and the virtual networks that you have in Azure, which will enable you to build your hybrid applications in Azure. So the use case here is when you have the cross premise, okay, which goes beyond the speed of 100 Mbps, which is nominal over here on the throughput, you will be connecting with this IP level connectivity. So here you have multiple data centers, which is at on premise, and you have multiple data centers, which is at Azure on different VNet environments. Okay, before going to this express route, any questions on site to site and point to site? Well, so let's go for this Microsoft Azure Express route. The Express route is a private connectivity which processes high throughput, and it establishes the connection between the Azure data center and the on-premise environment. Okay, so this will go up with the public internet so that you can have the more reliability. That is, you don't have a huge latency or anything like that. It fastens the speed. It has a private connectivity with the WAN providers, and it fastens the speed. And it also provides low latencies and high security here. The site-to-site VPN and the express route has major differences. So in the cross premise that you have, that you can see it on the screen, that's the connectivity towards the Azure data centers, which is enabled by the site-to-site VPN connection. And when you go for the site-to-site VPN connection, the public internet will not offer the same advantages which are given in the previous slide that you have. So the best way that you can go is you go for the express route when you have the cross premise. The different options that you have for connecting with express route is that you have an exchange provider and you have a WAN provider. The exchange provider is where it comes up with a dedicated fiber connection. You can find it on the picture here. It has a dedicated fiber connection. It establishes the connection from Microsoft Azure towards the express route location and for the customer site. Whereas the WAN provides the connectivity from Microsoft Azure towards the WAN using multiple customer sites. Okay, so it connects from a WAN provided by network service providers. So here are the scenarios where you can use the express route. If you want to take a backup and recovery on a cross premise, on a hybrid application, or even on a data center extension, something like that, then you will use this express route. So the demo for the express route is where you go up with establishing the gateway and then you need to establish the connection. Okay, so it's not possible since we don't have any on-premise here. Still, I will show you how you can do that. Okay, you can just go for the Azure portal. And here you can search for express route. So you give the circuit name, the private connection, peering location, all these things. We don't have the private connection here, so I'm not creating it. Just makes sense. Okay, and don't worry, you don't have questions on creating all. Okay, so you don't need to worry about it. But just make sense on the express route. Okay, how to extend your environment as such. Let's check if the application gateway is created. Yes, the application gateway goes here. So in this application gateway, let's go for the backend pools and you should find the app gateway backend pool here. It's getting updated. Okay. And in this backend pool, you can select the virtual machine in targets in order to point the application gateway. So you go here on the backend pool. Okay. And you can set it from the virtual machine and you can call the virtual machines here. See, you can call the virtual machines. Okay. You just call it and you click on save. It gets updated. Then you need to go for the backend pools again. Let it get loaded. So let's go up here and you can put up the IP address. So you go for the IP address, okay, and you give the IP address of the machine here. So the traffic from the public internet goes to the application pool now, and from there it can go into one or more load balancers. Okay, I showed you the picture. I hope you remember. From there, it will go into one or more virtual machines. Okay, and that creates a sophisticated global environment for the data centers that you have in a single application gateway. You can also go up with a cookie based affinity. So for cookie based affinity, you can go for HTTP settings. Okay, so what you do is you just close this and go for HTTP settings, and you will be having app gateway backend. And here you can just click on enable for cookie based affinity and you can request the timeout over here. Okay, the requested timeout, all these things. So that's cookie based affinity that you have in the application gateway. And next you have rules. Okay, so what you can do for this is you go for the application gateway window. Should have, they have changed it. Give me a second. Yes, you have rules here. So you go to the rules and you can add the rules here. Okay, so this rule is commonly like what sort of type you are going to allow with all these things. I can show you here. Let's click here. See the listener whom it's going to and the backend, the HTTP settings. You need to set all these things here. Backend pool is also a kind of reducing network traffic. Tarak, it's not reducing the traffic. Backend pool is you're looping the virtual machines on it. Application gateway is reducing the network traffic. Okay. The backend pool is to add the virtual machines. Same the load balancer also you will be adding it. I hope you remember in load balancer also you have backend pool. Okay. Rules is like health props. Rules can manage whatever the settings you have given. See, it says who is the listener, who is the backend pool. So the backend pool has the virtual machines. Listener listens the HTTP traffic. Okay, and the HTTP setting says for how many timeout it has to wait as such. So you give all those things over here. Are you clear, Vipul? Okay. So the next demo, the final one, is about creating a VNet gateway. Okay, I hope you guys know for what we are going to do a VNet gateway, right? The VNet gateway is for again the cross premise and the extended environment. So for the virtual network gateway, you just go here and you search for either you go to the networking or you just search for virtual network gateway, and you can click on create. So this will help you to connect with the express route or with VPN. So whatever we have discussed so far, you can find it here. So I will say Edureka VNG. The gateway type, let it be a VPN itself, and the VPN type will be based on the route based. Okay, so you have types of VPN where you can choose. That depends on make and the model that you have. So let's go for this SKU, and here I will say I will select VPN gateway 1, and this enabling the active mode is like you need to go up with a route based VPN gateway for higher performance, then you can enable it. And next is your virtual network. I'll select the VNet which we have. Public IP address, let's go for existing one. So I have this Edureka public IP address. And then you have this configuring the BGP, all these things. Okay, BGP ASN. See, the BGP ASN is the standard routing protocol. Okay, which is used for the internet to exchange the routing and reachability information between the networks that we have. Now here the Azure VPN and the on-premise VPN will exchange the routing reliability reachability information. So that's what we call it as BGP peering here. If you need, you can enable that. But as of now, we don't need those things. So I'll just click on create to get it created. Oh, sorry. I will associate with the lab VM. Let's click on create. Okay, let's do one thing. I'll create a new one. Edureka VG VNG. So deploying this will take around 45 minutes for you. Okay, it's same. It's not just with Azure. It's common with all those. So that's how you can put up the VPN gateway. Any questions? This VPN gateway is used to VPN virtual machine we created. Yes, Vipul, you're right. But we should also have the on-premise. We did not connect for the on-premise, right? We should also have that. Okay, so that's the end for today's topic. It will get deployed, okay, after 45 minutes, and you can make sense of that. So by that we come to the end for today's one. As a summary, we were working with the complete VNet, the networking components that we have, like virtual network, the application gateway, load balancer, VPN, okay, the virtual appliances that we have, and also with your load balancer, okay, and creating a virtual machine with all these things. So let me know if you have any questions, and please work on the demo. Find time to work on the demo, okay? And yep, of course, I will share the document for this. Okay, don't worry. Today I will share it. Okay, I have the video with me. I can even show you guys. I have the video uploaded on the drive. Okay, I just wanted to share with you guys. That's it. I have it on the drive. I converted it. Okay, I have mail from Rishabh as well. I will respond for that. See, I have it here. Okay. So don't worry, I will share this video. Okay, once when I log off now, immediately I will do it. Okay, and I will also convert this recording and I will share it to you guys. Okay, any other questions? Chandu, you can write me on my email ID, please. I don't often pick my calls. Okay, I already told you guys yesterday, Chandu and Pawan, everybody. I will upload it on the YouTube channel and you get it from there. Okay. You can find the updates on the LinkedIn page of mine, on the company page, and Twitter, all these things. I shared you the details by yesterday itself. I'll share it even once again. So you can find the updates from there. Okay. Hi, Firoz. I have to learn PowerShell for Azure. Suggest me any source, please. Pavan, whatever the resource that you need, like you go to this documentation, okay, and there you select the one which you need. For example, let's say you want to go for blob storage. Okay, you go to the blob storage and there you can find PowerShell. For each and every one, everything they have PowerShell. Okay, you can just click on this and you will get the PowerShell requirements. Cool, guys. Let me know if you have any other questions, please. Well, I hope we can close for the day then, right? How to find the video in YouTube? Tarak, go to this channel, okay? Subscribe it so that you can get the mail automatically. So in this videos, you will be having it. Yes, I will create a playlist and I will upload it. Okay, I will create a playlist and I will upload it over there. Well, guys, thank you so much for joining. We'll see you guys by the next week. Okay, thank you. Bye bye.